Okay, geometry group, we are in section 5 of chapter 5, indirect proof and inequalities in one triangle. Pause the video, answer the questions, come back and check your work. The conditional would be if a triangle is isosceles, then it has two congruent sides. Remember contrapositive? It would be if not P, then if not Q, then not P, right? So if John does not have a piano lesson, then it is not Tuesday. And what counterexample did you come up with? Probably 7, right? Okay, today's objectives: write indirect proofs and apply inequalities in one triangle. So far you have written proofs using direct reasoning. You began with a true hypothesis and built a logical argument to show that a conclusion was true. In an indirect proof, you begin by assuming that the conclusion is false. Isn't that interesting? Then you show that this assumption leads to a contradiction. This type of proof is also called a proof by contradiction. So when we write an indirect proof, we follow these steps. Identify the conjecture to be proven. Assume the opposite, the negation of the conclusion, is true. Isn't that interesting? And then we use direct reasoning to show that the assumption leads to a contradiction. Conclude that since the assumption is false, the original conjecture must be true. Oh, here's a hint. When writing an indirect proof, look for a contradiction in one of the following: the given information, a definition, a postulate, or a theorem. Okay, here is one example laid out for you. Write an indirect proof that if A is greater than 0, then 1 over A is greater than 0. So first we identify the conjecture to be proven. Excuse me. Given A is greater than 0, we're asked to prove that 1 over A is greater than 0. So that was given, right? So we're going to assume the opposite of this conclusion. So let's assume the opposite, which would be 1 over A is no longer greater than 0, but is less than or equal to 0. And then we'll use direct reasoning to lead to a contradiction. Okay? So we write our assumption. If A is greater than 0, then 1 over A is less than or equal to 0. This has the opposite conclusion, right? And then let us see, what do we do to both sides here? We could multiply both sides here by A, right? If we do, this is the, we're just multiplying both sides, the multiplication property of equality, right? And when we multiply the right side, 0 times A is 0. So we have the 0 property of multiplication. And when we simplify, we end up with 1 is less than or equal to 0. Is this a true statement? No, this contradicts. This is not true. So, conclude that the original conjecture is true. The assumption that 1 over A is less than or equal to 0 is false. Therefore, 1 over A is actually greater than 0. Write an indirect proof that a triangle cannot have two right angles. So first, we're going to identify the conjecture. A triangle's interior angles add up to 180 degrees. We're proving a triangle cannot have two right angles. So assume the opposite of the conclusion. So we will assume that a triangle has two right angles. Use direct reasoning to lead to a contradiction, right? Okay, so we know that the angle sum theorem tells us that the angles of a triangle add to 180. And let's substitute two right angles, right? Two 90-degree angles. Triangle has two right angles, we're saying. We put those in. 90 plus 90 plus the unknown angle equals 180. 180 we can see plus the unknown angle equals 180. So now angle 3 equals 0. Is this conclusion valid? It is not, right? We know that a triangle cannot have an angle with a measure of 0 degrees. That is a non-angle. That's not an angle, right? And therefore, since this conclusion is not true, the original conjecture is considered to be true. The assumption that a triangle can have two right angles is false. Therefore, a triangle cannot have two right angles. The positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. So, actually, if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So look at side AB here. AB is longer than BC. So angle C, which is opposite the long side, is larger than angle A, which is opposite the shorter side. Okay? And if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So if we know that angle Z has a larger measure, is greater than angle Y, then we know that the side opposite angle Z, XY, is greater than the side opposite angle Y, XZ. Okay, so you can see these are closely related. They are just the inverse of each other, right? So let's write the angles in order from smallest to largest here. And given what we've just learned in our angle side relationship theorem, right? We know that the longest side would be opposite the largest angle, right? So that angle must be angle G. The shortest side is GH, so it must be opposite the smallest angle, angle F. So if we put these in order from smallest to largest angle, we would have angle F, angle H, and angle G. Let's write the sides in order from shortest to longest. Go ahead, pause the video and come back. Okay, you probably figured the measure of angle R because we need to compare these angle measures, don't we? 60 plus 72 is 132, right? So our missing angle must be 48. Right, so if this is 48 degrees, then the side opposite it is the shortest. PQ is the shortest side. The next shortest side would be opposite the middle angle, right, which is the angle with the measure between the other two, 60 degrees, so QR. And finally, the longest side must be opposite the largest angle, which is then PR. So PQ, QR, and PR. A triangle is formed by three segments, but not every set of three segments can form a triangle. This is such a fascinating topic. So segments of 7, 4, and 4 can form a triangle, but segments of 7, 3, and 3 cannot. If you take little, popsicle sticks and cut them into lengths that are centimeters, 7 centimeters, 3 and 3, you'll see you can't reach those 3 and 3, just can't make it to each other's endpoints, okay? So when we think about this, why can 4 and 4 reach across and 3 and 3 cannot? It has something to do with the length of this long side, doesn't it? So a certain relationship must exist among the lengths of the three segments in order for them to form a triangle. The sum of any two side lengths of a triangle is greater than the third side length. Must be. Let's look back here. The sum of 3 plus 3 is not greater than 7, so they can never reach. Imagine even if you lay them down flat, they will not cross this length of 7. They would only cross a length of 6, right? While 4 and 4 is 8, 4 plus 4 is 8, So there is the ability for these segments to reach out and touch, right? So AB plus BC must be greater than AC. And then BC plus AC must be greater than AB. And finally, AC plus AB must be greater than that third side BC. This is the triangle inequality theorem. So tell whether a triangle can have sides with these lengths and explain. Pause the video, put your answer down, come back. And hopefully you said, no, triangle cannot have lengths of these sides because 7 plus 10, those two sides are not greater than 19. The sum is not greater than 19. It couldn't cross that span, right? So by the triangle inequality theorem, a triangle cannot have these side lengths. Could a triangle have these side lengths? So again, you're testing, right? Testing, adding to see if the sum of each pair is greater than the third side, right? The sum is greater than that third, and these two are greater than that. It looks like this set will work. So here we have testing, and yes, the sum of each pair of lengths is greater than the third length. So yes, a triangle can have sides with these lengths. Tell whether a triangle can have sides with the given lengths and explain. Ooh, these are fun. Okay, so what are you going to do? Evaluate. Plug in 4. Go ahead and come back and check your work. Okay, so you found that this was actually equal to 10, right? And the second segment is equal to 15, and the third segment is equal to 12. So we had to find those values, and then now we have to test. Will a triangle be possible with side lengths of 10, 15, and 12? Look, we just add 25 is greater than 12, 27 is greater than 10, and finally 22 is greater than 15, so yes. When we compare them, they're meeting our criteria. The sum of each pair of lengths is greater than the third length. Go ahead and pause, come back and check your work when you're ready. Okay, and for number 1 we have, and number 2. And don't forget to pause, come back. And the range of the possible lengths of the third side would be, the range would be values between 5 and 29, right? Tell whether a triangle can have these lengths? No. And can the other two distances shown be 8 and 6 feet? And yes, those sums work. And there you go.